Hello everyone, this is Mr. McMillan and I'm here with another instructional video, this time on triangle congruence, postulates, and theorems. So in the previous lesson we discussed how to determine congruence using the corresponding parts of polygons, and we mainly focused on triangles, but it's the case with all of them. If all corresponding parts are congruent, then the triangles are considered congruent. Okay? So remember, all corresponding parts are congruent, the triangles are congruent. In today's lesson, we will be discussing congruence postulates and theorems that relate specifically to triangles, okay? And there's 5 that we're gonna be talking about, okay? And they are listed here in this chart, and we're gonna fill in these, the chart based on these diagrams, okay? Let me adjust my focus here so it doesn't switch back and forth here. All right, so let's look at each of these. So our first postulate theorem we're going to be talking about is called side, side, side. This is the side, side, side postulate, and we abbreviate that using SSS, right? So we have our side, and our side. Okay, so SSS, and I am going to be using different colors based on the information that we have in the diagram just for this video, just to kind of show you exactly what we're talking about here. Okay, so if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. That's all that the side, side, side postulate says. So you're looking to see if all the sides in your first triangle are congruent to all your sides in the second triangle. So let's look at this diagram here. We're going to fill in these blanks. So let's look. We're looking for sides, right? Now remember that you have congruent tick marks here. And the congruent tick marks means that the sides that have the same number of these ticks as the other are congruent to one another. So if it has 1 tick mark, then it's congruent to on the other triangle that also has 1 tick mark. Does that make sense? So let's look here. The first one we're going to talk about is CK. So we're going to start out with CK. I'm going to start out with red here. So we're going to start out with this side here. Okay. So CK, it has 1 congruent tick mark, and we need to find the one on the other triangle that has 1 congruent tick mark, and we see that PX has that. So I'm going to put an S here, okay? And then I'm going to write, we have CK is congruent to PX. Okay. All right, now we're going to move on to the light blue, and we're going to look at our next side. Well, I'm looking at the CE, which has 2 congruent tick marks. So I've got 2 congruent tick marks here, and I'm looking for 2 congruents on the other one, which is PN. So CE is congruent to PN. And then finally, I'm going to move on to our purple here, and that's our last side EK, which has 3 congruent tick marks, which is the same as XN. So EK is congruent to XN, excuse me. So if all 3 of these are true, if you have your side, side, side postulate, all 3 sides are congruent, or you have 3 pairs of congruent sides, that means that those 2 triangles are congruent. And that's all you need. You wouldn't have to know anything about these angles. You would only need to know that the sides are congruent. So basically, these are shortcuts that are well documented to be true in order to prove triangle congruence. Okay, and there's a bunch of proofs that go into that, but we don't talk about it in here. Okay, so let's look at the next thing. Next one is side, angle, side. Now I'm going to point out something here, is that the order of these is very important. Okay, we're going to talk about why when we look at this, but the order in each of these postulates is incredibly important to identifying the correct postulate or theorem to use. So we have side, angle, side here. And so if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. And all it means by included angle, when you see included angle here, if you're included in a group, you're in between, you're in with a bunch of people, right? You're in between people. You're amongst people, right? That's the same thing with these angles. When we say an included angle, we mean angles that are between the sides. Okay, so we're looking for an angle that's between the sides. Now look at the way this is ordered. You have side, angle, side. Do you notice there that the angle, where it says angle, that angle is between the sides? Okay, so for side, angle, side, the angle has to be between the side. It can't be outside of the sides. Okay, so let's look at our diagram here. We have, the first one says it's a side, so we're going to look at the one congruent tick mark, and we're going to say RT here. And RT is congruent to which other side? Well, if we look at our diagram, we have one tick mark here as well. So that means that it's congruent to MW. All right, next up, we're going to look at our angle. And so our angle here, we have an angle right here. And the only other angle that's in here is M. So angle R is congruent to angle M. And then we have our side RY is congruent to ML. Okay, and so if we label this with our side, angle, and then side again, do you notice that this angle here in blue, do you see that it shares a vertex that touches both of those sides? Both of those sides have R as one of its point names, as its vertice or its vertex. Okay, so the angle that's between, you see how it's encapsulated in between the two sides. So if you were to draw that, you can ignore that and it just has SAS. Okay. All right, next up, we have angle, side, angle. So just like the other one here where it had side, angle, side, this time we have the sides that's in between the angles. Okay. So we have angle, side, angle. And this one says if two angles and the included side, remember, included side will just mean they're between the angles, of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So we have to start out with our angle here, then go to side, then angle. So let's look at that. We're going to start out with angle D. It has one congruent tick mark. And we see that S also has one congruent tick mark. So angle D is congruent to angle S. Then we are side. Our side is in between. I'm going to go ahead and put an A here for angle. Then our side, well, the only side that's marked congruent here is AD and SQ. So AD is congruent to SQ. And then our final angle here, which is angle A and Q. So angle A is congruent to angle Q. And you're going to notice something here. Where is that side? Well, that side, do you see how that side touches both of the angles? That side is in between That side is in between those angles because it touches both of them, okay? So think of it like this. If you have a tick mark or you have a measure here that is congruent and it's between those two angle measures, like you have angle, side, angle, then that means you're using ASA. All right, next up, angle, angle, side. Now notice here that the side is outside of the angles. It's not between them, okay? So that's important. This is not between the two angles, okay? So we have our angle and side. And here it says if two angles and a non-included side, so the side's not between the angles, of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. So we go angle, angle, and then side, okay? So if we look here, we have two angles that are going to be congruent to one another. We have Z and O because they have the same number of tick marks. I don't know what letter I was trying to make there. And then we have F and C. And we're going to go ahead and put angles or A's there. Keep forgetting to do that. And then our side, which is ZG and OU. Okay. So if we look here at our placements for our, we're just looking for patterns. We have AAS. Notice that the side only touches one of the angles. It doesn't touch both. If it touched both, it would be here and it would be included. Now you could have also had these two sides be congruent instead of these two, and you would get the same exact result. Okay. Then finally, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. So remember that the hypotenuse of a right triangle is the side that is opposite the right angle. Okay, so if you're looking here, your side opposite the right angle is your hypotenuse. Okay, so if triangle ABC and DEF are right triangles, then our hypotenuses have to be congruent. So I'm going to use red to do that and blue to do the leg. So the hypotenuses are AC and DF. And then the legs are BC and EF. Okay, now you could also have this other leg here. AB could have been congruent to DE instead of these two because it's still a leg. The legs always touch the right angles. Okay, so we'll put H, L, and L. Okay, now just because you see a right triangle does not mean that you're always going to use hypotenuse leg. You may use some of the other postulates as well. You just have to make sure you pay attention to the problem. Okay. All right. So this will be real short just because this is just getting you to think in the right ways for approaching these problems. So now that we are aware of the existence of triangle congruence postulates and theorems, let's look at some strategies on how to apply these to problems. So the first step we're going to be doing is looking for any information in the problem statement or from a provided diagram in the problem. If this information is not already marked, mark it in the provided diagram. This information may include, and there's 4 different things that we might include here. So the first thing is congruent statements. So we're looking for statements of congruence in the problem. For example, you might be given something like angle D is congruent to angle G, or you might have CF is congruent to XT. So you may be given a side or angle that are congruent, okay? Then it says how many congruent angles are stated, how many congruent sides are stated. And you would mark those appropriately on a diagram that you would be given. Next up is diagram markings. This is if you're already given a diagram with markings. So you're going to check for any congruency markings or measures in the provided diagrams. Remember that tick marks or lines are used for congruent sides, and semicircles or arcs are used for congruent angles. Okay, and the number matters. Shared sides. Does the provided diagram for the triangles have a shared side? A shared side counts as a congruent side for both triangles. This is because they are the same side. They are the same side, okay? So they're congruent. It counts for both of them. And then, of course, vertical angles. Is there a pair of vertical angles in the diagram? Remember that vertical angles are always congruent. Okay? So for each type of triangle congruence, you need 3 pieces of information. You need 3 pieces of information to use the postulates or theorems. Additionally, pay attention to how the angles and sides are arranged for each postulate or theorem. Okay? So, for side, 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 as the name implies, you need 3 congruent pairs of sides. That's all you need. But that is 3 pieces of information because you have to have 3 separate pairs of congruent sides. All right, side angle side, just as the name implies, you have 2 sides here. So you need 2 pairs of congruent sides. And then your congruent pair of angles with 1 pair of congruent angles between the 2 sides. They both have to be between the sides in their respective triangles. Angle side angle, you need 2 pairs of congruent angles with 1 pair of congruent sides that are between the 2 angles, as the name implies. Then you have angle, angle side. You need 2 pairs of congruent angles with 1 pair of congruent sides that is not between the 2 angles. Okay? And then for hypotenuse leg, you need right triangles, congruent hypotenuses, and 1 pair of congruent legs. Okay? Now, there are Some postulates that do not exist, these cannot be used to determine congruence. The first is side-side angle. If you have two congruent sides and one pair of congruent angles, the pair of congruent angles must be between and connected to both angles, okay? So you can't have an angle that's just outside here like this. You can't have this. Can't have that, okay? That wouldn't work. That side-side angle does not work, okay? Then you have angle, angle, angle. If you have three pairs of congruent angles, this does not mean you can prove congruence. Two triangles can have the same angle measures but have different side lengths. For instance, one triangle can be 3 times the size of another with the same angles. So just because you're given 3 pairs of congruent angles does not mean they're congruent. Now they would be similar, but that's not what we're talking about today. We're talking about congruence, okay? So that does it for this note video, guys. There will be some practice problems. We are going to, there will be another video on these example problems here. And hopefully we'll be able to get some of those covered and in a reasonable amount of time. We're kind of on a time crunch due to SOL testing. Anyway, thanks guys, and I hope this video helped. If you have any questions, please feel free to email me. Make sure you join the Zoom sessions to ask any questions, because I cannot help you unless you ask questions. All right, see you in the next video.